Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Here we are having another topic, and this topic is for class first year. And today our topic is TCPIP architecture. Before going further, we can see that what is TCP/IP. Communication between computers on a network is done through protocol suites. The most widely used and most widely available protocol suite is TCP/IP protocol suite. TCP/IP is an industry standard suite of protocol designed for local and wide area network. It was developed by the United States Department of Defense Advanced Research Project Agency (ARPA) in 1969 for a research sharing project called ARPANET. Internet was built on the foundation of the original ARPANET project, and this TCP/IP protocol are the product of this ARPANET project. So today we are going to see that what is TCP/IP protocol suite architecture. A protocol suite is a group of protocols that all work together to allow software or hardware to perform a function. That TCP/IP protocol suite is a good example of it. The three important points associated with TCP/IP protocol suites are TCP/IP architecture, TCP/IP ports, TCP/IP applications. So, dear students, as we already know about that, we when we communicate over a network from one device to another device, we need protocols to perform this communication functions between softwares and hardware. So we have some group of protocols which is called TCP/IP architecture. These protocols are the responsible of uh, sharing of data from one location to another, and all the responsibility of communication of data is responsible is main function of this TCP/IP protocol. So this TCP/IP protocol, we are going to learn about three main things. First, its architecture. Second, its ports, and third, its application. But today, only we learn about only TCP/IP architecture. TCP/IP protocol suites consists of four-layered architecture. This one, TCP/IP have four layers. With each layer have its own functionality. These layers are application layer, transport layer, internet layer, and network layer. And dear students, we already learned about the OSI model. In OSI model, we have already learned about the seven layer of the model. So in TCP/IP architecture, we have only the four layered architecture. We are going to learn about it. Which one is? The first one is application layer. The second one is transport layer. The third one is internet layer, and the fourth one is network access layer. And also you can see there this TCP/IP architecture, that this layer is application layer, this one is transport layer, internet layer, and all the interfaces, network interface layer, and then all these protocol suites are here on each layer. TCP/IP protocol suite have four layers, and each layer usually have more than one protocol. You can see that each layer have more than one protocol. Like if we are going to see this application layer, this layer have protocol telnet, FTP, SMTP, DNS, RIP, SNMP. All these are the protocols, and you can see these. You can also see these protocols on the page number 158 of your computer science book that all the OSI model have different protocols on different layers. So here, first layer, application layer, have these some protocols are here, and then transport layer have TCP, UDP. These two protocols are on the transport layer, and internet layer have this one, ARP, IP, IGMP, ICMP, and these protocols are reside in internet layer. And then network interface layer have Ethernet, token ring, frame relay, ATM. All these protocol suites make this TCP/IP protocol suites. So these protocols are reside each layer have many different. I am discussing with you that different protocols are there on different layers. It is named from two of the most important, and all these have combined with two main protocols. The first one is transmission control protocol TCP, and the second one is IP Internet Protocol. So now we are going to see the protocols. The first one, the application layer protocol. The first one is application layer protocol. It supports different users application, e.g. email, file transfer. It provides interface between human and network, resource sharing, remote file access, network management. So this layer is responsible for to deal with the sharing of some applications, and this one is the top most layer of the TCP/IP protocol suites. This layer includes application or processes that use transport layer protocols to deliver the data to destination computers. So this layer is the we can also say that this layer is provide the interface between applications and the transport layer, and this layer converts the data from application readable format into network readable format and give that data to the another layer which is called transport layer. So we can see that the application layer serve as an interface between user and application process on the network. The application layer is responsible for displaying data and images to the user in a human recognized and readable format. It provides an interface with the presentation layer and the and, and the next layer, transport layer. And everything at this layer is application specific, and this layer perform many functions: remote file access, electronic mailing, remote accessing, etc. and etc. The next R layer is transport layer. It's reliable data responsible for the reliable data exchange to make sure that all the data packets arrived in the same order in which they are sent out. Packets not received or received in error are retransmitted independent of network being used, independent of application layer. So dear students, you can see that this transport layer provides the means for the transport of data segment across the internet. The transport layer is concerned with the host to host communication. Transport Control Protocol provides reliable connection-oriented transport of data between two endpoint sockets on two computers that are internet protocol to communicate with each other. So when we are dealing with the transport layer, we can see that this transport layer provides different functions over here. As its name shows that it handles the transport of data between two devices, and also it is responsible of the flow of the control, error control, data segmentation, and communication reliability. So you can, if we are discussing about the transport layer, the main point of the transport layer is the responsibility. It has the responsibility to flow control. The flow must be continuous. The second is error control. It is responsible to remove the error, as I have already discussed over here. And then data segmentation. It is responsible to segment of all the data. The transport layer ensure that messaging are delivered error-free, in sequence, and with no losses or duplication. The transport layer provides some more functions. We can see that accept a message from the session layer, accept the message from different layers from the application layer. It split the message into smaller units and passes the smaller unit down to the other layer, which is internet layer. The transport layer at the destination station reassemble the message, manage reliable end-to-end message delivery with acknowledgement in the network. So this layer is also responsible for the acknowledgement. As we already know that there are some acknowledgement we can see if we are using some WhatsApp application, then we can see that when we send some data from our mobile, when data already sent by our mobile, the one tick is over there on our data post. And then when another person received that data, then another tick is appeared on our mobile. So we have to receive the two ticks on our mobile. Then when somebody see that data, then those ticks become blue, the color become changed and it become blue. This color shows that the acknowledgement of us, for us, that data already been delivered and already been seen. So this is called the acknowledgement process. Tells the transmitting station to back off where no message buffers are available, and also provides reliable and sequential packet delivery to error recovery and flow control mechanism, and also provides the communication packet delivery. And then we can see that internet layer provides global addressing schemes. It provides it process of marketization of data. No, it's not marketization of data. It provides the packetization of data. That is not a marketization of data. Sorry, it is a packetization of data. This layer protocol is have using IP, Internet Protocol. Then we have another layer which is network access layer. We can see that this one is network access layer. Exchange of data between the computer and the network. Sending computer provide addresses of destination so that the network can route different switching and network techniques, circuit switching, packet switching, LANs, etc. This layer may need specific drivers and interface equipments depending on the type of network used, but upper layer do not see these detail independence property. So we can see that network access layer provide access to the physical network, and this one is the dealing with the physical connection and physical network. The data is transmitted and received across the physical network in network access layer. The layer combines the physical and data link layer and routes the data between devices on the same network. It also manages the exchange of data between the network and other devices. So between other devices. So here we can see that today we have been seeing of this TCP/IP architecture. What is TCP/IP architecture? It is a suite of group of protocols, which multiple protocols when combined together and working together on four different layers, then it's become a TCP/IP protocol suites. And each layer have different functions and each protocol have different functions. So when we are going to learn about TCP/IP, then we have three main points. The first, TCP/IP architecture, the second, TCP/IP ports, the third one, TCP/IP applications. And then we have seen about this TCP/IP architecture, which consists of four layers. The first one layer application, the second one layer transport layer, and third one is internet layer. The fourth one is network layer. So we can see that these are the most four layers are available in this TCP/IP architecture. Then we are going through these four layers having all with these protocols. This layer have this type of protocol, this layer have this type of protocol, and this layer have this type of protocol, and the last one layer, the physical, the which layer deal with the physical connectivity, physical network have this type of protocol. Then we already have a look upon these layers differently one by one. The first one is the physical layer, which addressing the application, using the application, interface between human and the network, resource sharing, remote file access, network management, etc., etc. And then we are going to have a look upon the transport layer, which is the next layer of application layer, which is reliable of data exchanges, packet receiving, error recovery, flow of data, responsible for the flow of data, error-free data, and reliable, and make sure that there is no duplication, there is no error on the network. This layer is responsible. And then we are going to have this uh, internet layer, internet global addressing schemes, and provide packetization of data layer, protocol use IP addresses, etc. And then we have a look upon this network access layer with exchange of data between the computer and the network, sending computer provide addressing of destination, uh, and it's responsible for the manage to exchange of data between the network and the other devices. So that's all for today. Thank you.